Intro Algebra Lesson 2-7A. So today we're going to basically start talking about the concept of what a reciprocal is. And as far as a reciprocal is concerned, it's dealing with fractions and then taking that fraction and flipping the numerator and the denominator. What's interesting is you can always tell if you have a reciprocal based on this concept that any reciprocal multiplied by the original number, or an original number multiplied by its reciprocal, will always equal 1. One of the biggest mistakes people make about reciprocals is they think they mean opposites, so that if one is positive, the reciprocal has to be negative. And that's not true at all. They should stay the same sign. They're literally just flipping the numerator and the denominator. As an example of this, I'll make this a little bigger. If we said this was our original number right here, 4/5, then this would be the reciprocal because it's flipped the numerator and the denominator. So the actual reciprocal is this value here. Alright? And if you multiply fractions tops times tops, you get 20. Bottoms times bottoms, you get 20. And anytime the top and bottom are the same, you have 1. So notice I didn't make the reciprocal a negative. It's exactly the same as it was when it was a positive. It just flips the numerator and the denominator. Sometimes people aren't sure how to find the reciprocal of a whole number or an integer. Well, any whole number or integer can be made a fraction by putting it over 1. That means the reciprocal then would be the flip of that, numerator and denominator. They multiply straight across, and you'd end up with 2 over 2, which again makes 1. So any number can have a reciprocal as long as you can write it as a fraction. And any integer can be written as a fraction by putting it over 1. Now, we have a division rule, but I don't want to get caught up in the division rule because in fact, it just means to multiply by the reciprocal. So a lot of us struggle with division and we get all bent out of shape about division. Just remember, division is multiplication in disguise. So you can actually twist it a little bit and create yourself a multiplication situation. If you look at this, 2/3 is being divided by 1/4. Now I don't want to try to take this fraction and divide it by another fraction. That's complicated. But what you'll notice is the first number stays exactly the same. Nothing's changed. But over here, this got flipped. That's the reciprocal. So we never flip the first number. Never. Yeah, but no. Never flip the first number. Only flip what you're dividing by. Then once you turned it into a multiplication problem, notice it was division, now it's multiplication. Multiply straight across, you get 8/3. You do not have to transfer the improper fraction into a mixed number. You certainly could if you'd like to, but you don't have to. Division to multiplication, second fraction must get flipped. That's the key. If you can do that, then you'll get it. Now, we had special rules for adding positive and negatives. We had special situations when we changed subtraction to adding the opposite. We have rules for multiplying all of these positive and negative numbers. So does division have its own set of rules? No. In fact, they're exactly the same as the multiplication rules, which would make sense because you are multiplying by the reciprocal. It would be kind of strange if division was multiplication in disguise and we had to learn different rules. It's got to have the same rules as multiplication, okay? The sign of a quotient, you can look on page 109 if you'd like, but it is just like multiplication. It's exactly the same as multiplication. In other words, if you have the same signs or an even number of negative signs, you're going to get a positive. A negative divided by a negative is going to equal a positive because there's an even number of negatives. And if you have an odd number of negatives, a negative divided by a positive, you're going to get a negative answer. You basically have this scenario. Negative divided by negative, not a very good G, is going to equal a positive. A positive divided by a positive is going to equal a positive. When they're the same sign, you'll always get positive. But if it's a positive divided by a negative, you're going to get a negative. And if it were flip of this, negative divided by a positive, you're going to get a negative. You have 4 situations of what you could have. Same signs, positive. Different signs, negative. All right, let's try some. Now this is a positive being divided by a negative. Since they are not the same sign, I know the answer is going to be negative. Let's practice what we've been practicing, which is to write each of these as a fraction. And now, 15 over 1, we never flip the first fraction, is going to get multiplied by the reciprocal, which is going to be 1 over negative 3. Now I realize you wouldn't necessarily have to do that on this problem because most of you can probably take these and divide them, but we want to practice that skill. 3 goes into itself once, and 3 goes into 15 5 times. That's called cross-simplifying. Finding a number that can go into both of those. 3 can go into both. Now since this one was a negative, I need to keep that as a negative 1. Fractions multiply straight across, so 5 times 1 is going to equal 5. And 1 times negative 1 equals negative 1, which means we're really dealing with negative 5. And good, it came out negative, which is exactly what we thought it should come out. I realize that you could probably do 15 divided by 3 and get the same answer, 15 divided by negative 3, but we want to practice that concept of multiplying by the reciprocal. Alright, the first number is an integer, so I can write it as a fraction. I'm not going to do anything with the first number. Negative 45 over 1 stays the same. I'm going to turn this into multiplication, and this is going to flip over and become 6 over 5. Now I have a negative being divided by a positive, so I already know that this better equal a negative answer, because they are not the same signs. And 5 goes into itself once, and into negative 45, negative 9 times. Fractions multiply straight across, so negative 9 times 6 is going to equal negative 54. 1 times 1 is 1, which means we get negative 54, which is good. It matches up with the fact that it's a negative value. This part right here, the cross-simplifying, is sometimes hard for people. They aren't quite sure how to do that. Remember, you are trying to think of a number that will go into this evenly and go into this evenly. Certainly there's other numbers that might go into 45, like 15, for example, goes into 45, but it doesn't go into 5. You have to pick something that will go into both of them. This is called a complex fraction, because it's a fraction inside a fraction. But just remember what you already know is that that line right there means division, which in fact means this could be rewritten as 2 1/3 being divided by negative 3. Now this is a format very similar to what we've been working on. What you need to do though, if you have a mixed number like this, turn it into an improper fraction. 2 times 3 is 6, 6 plus 1 is 7 over 3, and instead of this, division of negative 3, that can be written as a fraction, and we'll end up making this multiplication. We flip this over, and it's now 1 over negative 3. And then fractions multiply straight across. Nothing cancels out in this problem. So 7 times 1 is 7, and 3 times negative 3 is negative 9. And that would be your final answer, negative 7/9. I just want to remind you, negative 7/9 can be written this way. It can be put in the middle, the negative sign in the middle, or it can be given to the top. So you can have it on the bottom, the middle, or the top. They all represent the exact same fraction. What you can't have is on the top and bottom. Oops. That would not be the same. Because when you have two negatives, you actually have a positive answer. These are all negative answers. This, however, is equal to that fraction. So this is just kind of a reminder. It has nothing really to do with that top problem, other than the fact if you want to make it a negative 7 over positive 9, that'd be the exact same value. Another complex fraction, a fraction inside a fraction. This line right here means division, so you have negative 1 is being divided by 2/3. We're going to make that negative 1 over 1. We're going to make that multiplication, and we're going to flip this over and make it 3 over 2. Now the fractions multiply straight across. Negative 1 times 3 is negative 3. 1 times 2 is 2. There is nothing wrong with leaving it as an improper fraction. If you want to, yes, you could say it's negative 1 1/2. They're the exact same value, but there's nothing wrong in algebra with having that improper fraction. And lastly, negative 10.4 is being divided by 1.3. This is still a negative divided by a positive. So a negative divided by a positive is going to equal a negative. So we already know we better get a negative answer. Since I know the signs are going to be a negative, I'm not really going to worry about the signs right now. One other piece of information. if you do division with longhand, the first number goes in the box, and the second number always goes outside the box. So if we were to set that problem up, here's my box, and I would put inside the box the 10.4, and I would put outside the box the 1.3. Now what you do is you move the decimal over one place to make this a whole number, but if you move the decimal on the outside one place, you must move it on the inside one place as well. So we're actually dealing with 13 going into 104 with the decimal there. Now, can 13 go into 1? No. Can 13 go into 10? No. Can 13 go into 104? Certainly. 13 times 10 is 130, so it must be less than that. I think 13 times 8, let's take that as a guess. 8 times 3 is 24, carry the 2. 8 times 1 is 8, plus the 2 makes 10. Go figure, it goes in exactly 8 times. So 8 times 13 is 104, and we've got no remainder. Now we already said the answer should be a negative, so we'll say this is negative 8. Now if I take this value here, and I clone it, and I'm going to look at it again, similar to what we've been doing. This negative 10 and 4/10. That's in the tenths place, and there's 4 of them. So this is negative 10 and 4/10. Being divided by, that's a 3 in the 10th spot, so that's 1 and 3/10. Make them improper fractions. 10 times 10 is 10, plus 4 is 104. So we have negative 104 over 10 being multiplied, or we'll do division for right now. 10 plus 3 is 13/10. Now, instead of dividing, you will multiply by the reciprocal. Then the 10 on the top and the 10 on the bottom cancel out, and in fact, this is harder for people to see, 13 goes into itself once, and it goes into 104 8 times. So now it's a negative 8, and fractions multiply straight across. These are 1s because they cancel each other out, and you've got negative 8 over 1. Which is negative 8. Same exact answer. So a couple keys. People forget when you have fractions and you're dividing, they forget to multiply by the reciprocal. They'll switch it to multiplication, but they'll forget to flip it. Another mistake is people flip the first number. Don't mess with the first number, only flip the second number, and then turn it into multiplication.